Okay, class. Part 2 of our lecture on HR measurement picks up with coverage of the remaining two principles of validity and utility. Once again, validity refers to the accuracy of measurement using selection techniques. Yeah? Does our selection tool measure what it is supposed to measure? And that is, the selection tool should not be systematically biased in some way. And that, class, is the key difference between validity and reliability. Yeah, reliability is measurement that is inconsistent because it has random noise. Yeah, you see the dots are scattered away from the bullseye. Yeah, here with validity, it's really a systematic bias of missing the target systematically in a certain direction. Yeah, so selection tools are valid when they are accurate and have minimal systematic bias. So when you think about validity, there are three types or approaches that are quite helpful. The first is content validity, the second is criterion validity, and the third is construct validity. All three types of validity are important for all selection tools. Yeah. So content validity, class, refers to the completeness and fidelity of the selection tool. Yeah, for example, a good final exam should cover all the topics in the unit approximately evenly. If any topics are left out, then the exam lacks content validity. You can apply this premise to any selection tool. For example, you can design a situational judgment test to assess how nurses deal with complex care situations. But if your questions only focus on acute care and not on chronic care, then your measure lacks content validity. It's only capturing part of the construct space of complex care situations, only acute, not chronic. Yeah. Now, as a general principle, class, you want the content of the selection procedure to also link as tightly as possible to the actual job content. Yeah. The tighter the alignment here, the greater the content validity. Class, it's worth noting that content validity is a matter of expert judgment. We typically assess content validity by asking domain experts to evaluate our selection tools for completeness. Yeah, it's a judgment call. So what makes a measure lack content validity? First is incomplete coverage of the construct. Yeah, like the example earlier, a final exam that only covers weeks 4 to 10, not the full range of the unit. In that case, the final exam, lacks content validity. Yeah, it should cover the construct completely. Second is fidelity. How closely does the selection tool match how the construct actually manifests at work and thereby influences our criteria? So one example is testing math ability among job candidates for a bookkeeping role. Typically, you want bookkeepers who are good at math. Yeah, but let's say you test it by giving them like an old school paper and pencil math test with 3-digit numbers to add, subtract, and multiply. Just like 100 of these to solve. I mean, yeah, that would be a measure of mathematical ability, but it doesn't actually line up with how a lot of math is done in practice by bookkeepers or by accounting assistants, which is typically using spreadsheets. Yeah, so a test with more content validity would involve working with spreadsheets. Yeah. Next, we have criterion validity. Here we test if our predictors actually do their jobs of predicting our criteria. Yeah. So do our job interviews predict performance on the job? In jobs where safety is a major consideration, do our situational judgment tests predict employee safety outcomes? Do our measures of personality and intelligence in the selection process predict sales performance on the job? Yeah. Now, we typically assess criterion validity by collecting data on both the predictor and our criteria, and then we conduct a correlation analysis. This correlation analysis gives us a Pearson R statistic named for Carl Pearson. Typically ranges from -1. Not typically. It only ranges from -1 to +1. A correlation of 0 means that the predictor and criteria are not correlated. Like, let's say if your predictor is how much cheese you eat and your criterion is how satisfied are customers with your service. These two things should be effectively unrelated, should have a correlation of 0. Yeah. Now, let's do a quick statistics revision on correlations because this is going to come up a bit throughout the unit. Yeah, here we see a bunch of correlations. So X would be the predictor, Y would be the criterion. Yeah, here we have a positive relationship, a negative relationship. This is what a scatter plot, if the relationship is 0, would look like. There is no trend for X to Y. Higher scores of X do not predict higher scores in Y. Here we have a clear positive relationship. For example, your X could be conscientiousness and your Y could be job performance. Yeah, every dot point on the scatter plot corresponds to one person with ratings on both conscientiousness and job performance. So this person is highly conscientious and has high performance. This person is not very conscientious and performs poorly. There's a positive relationship because the two go together. Here you'd have a negative correlation, which means that lower scores on the predictor match up with higher scores on the criteria. Yeah. So for example, low scores on an integrity test can predict higher levels of retail theft or bullying. Yeah. Now class, see if you can work out if this correlation is positive or negative. Should be fairly straightforward. You'll notice the higher the score on sales ability in the inventory, the higher the score, the higher the criterion of job performance rating. Yeah, every employee is one dot point. So once again, class, the Pearson R statistic maps onto the correlations in the scatter plot to work out the strength and direction of the correlation. The strength of the relationship is how depends on how close the R statistic is to +1 or -1. If it's close to positive or -1, it's a strong relationship. Yeah, close to an absolute value of 1. If it's close to 0, it's a weaker relationship. We typically say, class, that a correlation of 0.1 is weak, 0.3 moderate, and above 0.5 is strong. The strongest predictor of job performance that we know of so far is intelligence, and scores on intelligence tests typically predict job performance at about R equals 0.5, which is a strong positive relationship, but it's not super strong. It's just 0.5, which just meets the threshold for strong. So class, one important property of the R statistic is that it not only captures the strength of the relationship, but when you square it, you get the percent of the criterion that is predicted by the predictor. So for example, we know that intelligence and job performance have an R of 0.5. Now, if you square that value, you get 0.25 or 25%. Yeah, what that means, class, is that intelligence predicts 25% of the variation in job performance. So people vary in job performance. 25% of that variation is predicted by intelligence, which is the best predictor that we have in the staffing world. That might seem a bit underwhelming, class. 25% doesn't seem like much, but that really, and considering that's the best we've got. But that is the reality of the situation. A lot of what goes into job performance, or really any of our criteria, are things that are unpredictable or due to aspects of the organization or the job design or the supervisor rather than the employee's KSAOs. And I should note that predicting 25% of job performance is a big deal when you think about tens or hundreds of employees performing 25% better consistently over the long haul. We'll get into that more when we go over utility. Lastly, consider whether a positive correlation is necessarily good or is a negative correlation necessarily bad. Yeah? What matters more is being able to predict the criteria. A negative predictor of criteria can simply be reversed when you do the math. It still predicts the criteria that matter. For example, a measure of team conflict can negatively predict teamwork. More conflict, less teamwork. But that actually makes team conflict a good predictor of teamwork because then we will know who are the people who will likely bring drama to the team and lower team effectiveness overall. If your predictor has a negative relationship with your criterion, that's good. It tells you who to rule out then, yeah, which is a good thing. Now class, how do we actually get criterion validity data? Well, for starters, we use data from workers. Let me fix that. Oh, I think that's better. Okay. Second thing is that criterion validity depends on the actual criteria. Yeah, so different selection tools are valid for different criteria. You wouldn't want to use an intelligence test to predict theft. You wouldn't want to use a measure of conscientiousness to predict creative performance. Yeah, you want alignment between the predictor and the criteria. So in class, I will prompt you regularly to clarify for any given selection instrument, what is it valid for? Yeah, so I'll ask you, valid for what? This instrument is valid for what? Interviews, behavioral interviews are valid for what? Work simulations are valid for what? Yeah, these are things we'll learn as we go through the unit. Now, class, the R statistic that we get from a validity study is called a validity coefficient. And that's how I will refer to it for the rest of the semester. This I will refer to as a validity coefficient. Now, there are two types of criterion validity, depending on how we collect data to get the validity coefficient. We can do so using concurrent validity, in which we get a bunch of people who already have the job, make them undergo the selection tool, say the interview, and then we measure the criterion, say supervisor rated job performance. And if it correlates, then great, we have concurrent validity. Now, class, concurrent validity is pretty fast because you just bring people in, have them undergo the selection tool, and get their performance evaluations from the system. Yeah, so it's pretty fast and it's pretty easy by far, but it is a weak test of criterion validity. Now, why do you think that is, class? Why do you think this is a weaker test? See if you can work that out yourself and let me know. Then, on the other hand, we have predictive validity, which assesses the selection tool among job candidates. Yeah, then it tracks them over time once they have the job, and then assesses the criteria once they've already been working on the job. So as you can see, class, predictive validity takes far longer and is far more resource intensive to verify, but it's also much more trustworthy and much more realistic. Here's some nice little graphic, class, on the differences between both criterion validation strategies. We have, for concurrent validity, we have current employees. We obtain their predictor scores and their criterion scores. For predictive validity, we get predictor scores from the job applicants and criterion scores once the same people become current employees. Now, class, with criterion validity, as you've worked out, one of the hardest things really is the time interval involved, especially for predictive validity. And it can be difficult to explain to managers why it's important to file all this selection information before using the data. Yeah, it can be quite tricky, but it is worthwhile. Lastly, we have construct validity. Basically, does the selection tool or test measure what it is supposed to measure? Construct validity encompasses the other two kinds of validity as well, including and as well as reliability for that matter. It also has a few additional requirements. So construct validity also requires clear dimensionality. What does that mean? Does the measure contain the right underlying clusters? For example, class, when we measure customer orientation, typically, the measure is designed to contain two clusters, or factors is the technical term. The two clusters are your ability to help customers and your motivation to help customers. Not quite the same thing. Similar, but you should see when you map out how the items fit together, a group of items capturing ability to help and a group of items capturing motivation to help. And so if you analyze your data and don't find evidence for these two clusters in your pardon me, in your customer orientation questionnaire, then it lacks construct validity. Next is convergent and divergent validity. These refer to correlations of your predictor, not with criteria, but with other measures. So let's say you're developing a new test of math ability. People's scores on your new test of math ability should correlate with people's scores on existing tests of math ability. Yeah, so it should correlate with similar tests. That is convergent validity. However, their scores on your new test of math ability should not correlate with measures of test anxiety. Yeah, people who have a lot of test anxiety should not score worse on your math test. We call that discriminant validity. This is checking whether your measure correlates inappropriately with nuisance measures like anxiety. Yeah, your measure should not be capturing nuisance constructs, but rather substantive constructs that actually matter for doing well on the job. So if your math test lacks discriminant validity, then people's scores on the math test will be contaminated by their level of test anxiety. Yeah, you have a contaminated test. And of course, lastly, a test can only be construct valid if it is also criterion valid, content valid, and if it is reliable. Yeah, so this is a high bar to pass class, and it's partly a judgment call based on all of this information. Okay, so really, construct validity is an accumulation of a variety of evidence supporting the links among various measures and constructs. And so here we have one example, a team orientation inventory. It should predict the criterion of peer ratings of team performance. It should measure the construct of motivation to work in teams. And it should generally be relevant to the job performance domain of working as a team member. Yeah? So there we have it, class, the three kinds of validity that a selection tool should possess. Now, class, one critical question is whether you need to conduct your own validity studies within your organization or whether you can just use existing data that's out in the world. This is a problem that HR professionals have been working on for decades. It's the situational specificity problem. It's the belief that selection tools' validity is unique to each job. So, if you have the same test of interpersonal skill, use it for 4 different sales jobs in 4 different organizations, wouldn't you expect the validity to depend on the sales job and the organization? After all, aren't all jobs unique and distinct in some way? If this were true, HR professionals would need to create and validate their own selection tools within their organizations every single time. Yeah? Now, this is something that is testable, and fortunately, what the evidence shows is that situation specificity has been debunked. Yeah? The best evidence we have actually supports so-called validity generalization. A selection tool that's valid for, say, sales in organization A is likely to be just as valid for sales in organization B. You don't need to do your validation all over again for a new organization. Typically, it should be valid anywhere, kind of, with some caveats, yeah? Typically, these results are consistent across similar jobs. Now, what this means, class, the upshot is that you can use existing validation research, like in the scientific literature, in other reports, to help you put together your selection procedure. But, undeniably, every job is truly different in some way. Differences across jobs can actually matter, and job analysis will help you work out exactly how big of an issue it is likely to be. Overall, class, what experts advocate for is a mix of both validity generalization, yeah, using existing data that's out in the world, and also local validation exercises that you would conduct in your own organizations. Lastly, we come to utility, yeah, which is the usefulness of the measure in terms of dollars and cents. Yeah, very, very handy thing to cover. So the example I mentioned in week 1 is the Philadelphia Police Department. Over 10 years, the contribution and the value for money of their intelligence testing was $170 million. And this was like back in the 70s. It'll be even more now. Yeah. The goal of a utility study is to take what we know from validation, yeah, and put it in terms that managers can appreciate and understand. So, typically, class, when we try to work out utility, we translate some information into dollar terms. So the first thing we do is we work out what is the financial benefit of being a high-performing employee. So if you meet all the criteria, you're a good employee, performance-wise, your teamwork is good, minimal theft, etc. Yeah, what does that translate to financially? Yeah, that's something to work out. Once you've worked that out, yeah, the benefit of scoring high on the criterion, then logically, if your selection tool picks people who score high on the criterion, then you're picking people who will bring value to the organization financially. Yeah, and so we need to work out the validity coefficient. How much does the selection tool actually relate to our criteria? Naturally, bigger is better. Then we have the selection ratio. If you are selecting five people for your graduate program out of 700 applicants, you're going to get a lot more value from good selection. Yeah, because among 700 people, you're going to see a lot more difference, yeah, in the KSAOs. And so if you select 5 out of 700, high quality selection will get you better value than if you're selecting 5 out of 7. Yeah, if there's only 7 people in your applicant pool and you hire 5 of them, why even bother going through a lot of the selection process? Yeah, it can be fairly minimal and still be a good value. It's really beneficial when you have a lot of job candidates and only few roles to choose from. Next is the base rate. This is a tricky thing to consider. Now, I've mentioned before how intelligence is a very useful thing to select for, but you'll notice that in many jobs, like say to become a doctor, to become a physician, they don't test for intelligence. Now, the reasoning for that is just to make it to the point where you're applying to a hospital, say to become a registrar, you would have had to do exceedingly well in school, do well on the GAMSATs, do well in medical school and survive medical school, and to pass through every single one of those hurdles, class, requires intelligence. So once you get to the point where you're applying for a medical job, you're probably pretty smart already. And so the base rate of intelligence in the applicant pool for a physician job is likely to be very high. And so if the majority of applicants are already smart, why test for intelligence? You're only going to pick up subtle differences. However, if the base rate is low, if in your applicant pool, intelligence is very variable and you may not find a lot of particularly smart people, then selecting for intelligence will get you a better value. You'd be more likely to find the few people who are likely to be superstars and really make a difference. Yeah? So, to get value for money, you want to work out, number 1, what is the financial benefit of being a high-performing employee in terms of the criteria? Yeah, work that out. Next, you work out the validity coefficient. To what extent does a high score on the predictor predict our criteria and thereby predict these financial benefits? Third, the selection ratio. If you are selecting a few applicants from a bigger pool, then high quality selection is much more important and much more valuable. Fourth, the base rate. If your KSAO is rare in the applicant pool, it is much more important to select for it. If it's common, maybe not. And this will help us work out the expected dollar gain from a selection process. Here's an example, class. So, using a mental ability test, in example 1 is worth approximately $59,200 to the organization in increased productivity and $59.20 per year per employee hired. Now, how they work that out, class, is, pardon me, multiplying these gains. So, how many applicants are they selecting? 10 people. Then we have the validity coefficient. People who score high on the mental ability test, 0.51 correlation with job performance. And people who perform well on the job are basically bring $12,000 worth of extra productivity into the organization. So we multiply 0.5 by 12,000 by 10 because there's 10 applicants, and we'll get to this base rate later. So that will give us the gain. Then the cost is, we're testing 100 applicants, and there's the cost of testing per applicant. Yes, we work out the costs as well. Gains minus costs, and we get this value. Now compare that class to example 3, the reference check. You'll see that it's mostly the same. We're still selecting 10 applicants. A high-performing employee still brings in $12,000 of extra productivity. It's otherwise similar. The cost is the same. We're testing the same number of applicants, but notice the validity coefficient is approximately half. Yeah, so reference checks do not predict performance as well as mental ability tests. And so we see that the gain to the organization is actually, instead of 59,000, it's only 29,000. It's a lot less because we've now chosen a selection tool that is a poor predictor of productivity. Yeah. Now let's compare these two examples of the mental ability test. Again, very similar, but note class that the average score of the people selected in example 2 is higher. Yeah, so here we have a base rate of intelligence that is lower, and so the people who do get selected tend to be smarter. In such instances, the payoff to the organization is even bigger. Yeah, there are examples of this that you can also work through in the textbook class. I think this is from the textbook. So, quick summary. Again, reliability is getting the same results consistently with your selection tool, whether it's consistent over time, consistent across items, consistent across forms, or consistent across evaluators. Then we have content validity. It should measure all of the construct that you wish to measure. Then we have criterion validity. It predicts what you want it to predict. Yeah? Construct validity measures what you think it is measuring. And lastly, utility, that it is worth it. And on that note, class, that's it. We are done with HR measurement. I hope you've been coping well with the coverage so far. If you're finding it challenging, reading the textbook will help provide some additional scaffolding for this material, and we'll also go over it a little bit in the tutorial, and you'll get a chance to work through an example, a very practical example at that. And we're done. Thanks again, class. See you next week for cognitive ability testing.